dear students. Last time I had introduced the topic of lever, and I had told you about the principle of lever. We had discussed that the mechanical advantage of a lever is equal to effort arm upon load arm. Today we will discuss kinds of lever. So there are three kinds of lever depending upon the position of the fulcrum. Okay, each type of lever has got different kind of mechanical advantage and different use. So we have the first kind of lever. The first kind of lever is one in which the fulcrum is in between the load and the effort. The load and the effort are at the extreme end. So class 1 lever. Class 1 lever. This is class 1 lever. Fulcrum in between, effort at one point and load at another point. Load and effort. Okay, this is class 1 lever. Now, mechanical advantage of this class of lever will be this arm, this distance. This is F fulcrum, so this is effort arm, and this is load arm. So, mechanical advantage of this class of lever is effort arm over load arm. What is mechanical advantage? Mechanical advantage is effort arm and load arm. Okay, upon load arm. So, here also there are three conditions that will arise in the case of the class 1 lever. Since the fulcrum is lying in between the effort and the load, and the position of the fulcrum is not definite, it's not at the midpoint. It may be anywhere between the two extreme ends of the rod. So the length of the effort arm and the load arm will vary. So mechanical advantage will also vary. It can have mechanical advantage greater than 1, equal to 1, or less than 1. So mechanical advantage can be greater than 1, equal to 1, or less than 1. If the mechanical advantage is greater than 1, it will act as a force multiplier. You must have seen plier, or class. इसको class कहते हैं. So class, where we hold the nut, that point from the fulcrum is very small, and where we apply the effort, that arm is longer. In that case, effort arm is greater than the load arm. Mechanical advantage is greater than 1. The plier behaves like a force multiplier. It's a class 1 lever. Example of class 1 lever. It has got fulcrum in between, about which it is rotating, and it is behaving like a class 1 lever. Then we talk about the second point. Mechanical advantage is equal to 1. Here mechanical advantage is equal to 1. Class 1 lever is acting as a change in direction. This is used for change in direction. Example, seesaw. You must have seen the seesaw. The length of the plank is equal on both the sides of the fulcrum. So the effort arm is equivalent to the load arm. Effort arm is equal to load arm. So mechanical advantage is equal to 1. Then we have another example of class 1. There are many more examples of first mechanical advantage greater than 1 force multiplier. Like you are opening the lid of the tin by using a spoon. So you raise the spoon over the mouth of the container or cane, and then you are opening the lid. Then the effort arm is longer than the load arm. In that case, it is acting as a force multiplier. Another example is crowbar. In crowbar also, the effort arm is longer than the load arm, and it acts as a force multiplier. Then we talk about the third one, mechanical advantage less than 1. Here it is used for gain in speed. scissors. In the case of scissors, the blade of the scissors are longer. The blade of the scissors are longer than the arm where we put the hands and the thumb to cut the scissor. As a result, the effort arm is smaller and the load arm is longer. So, the mechanical advantage of scissor is less than 1. It is used only to gain the speed. So, when m is less than 1, that is gain in speed. What about velocity ratio? In this case, displacement of load is greater than the displacement of effort. That is, the blades are moving to a greater displacement than the effort where we are holding the scissor. As a result, velocity ratio is also less than 1. So, mechanical advantage is less than 1, velocity ratio is less than 1. Then we talk about, there is another example that is given in the book. That is, a person who is sitting in the boat is rowing the boat with a long handle. So, he holds one end of the oar in his hand. In middle, it is resting on the side of the boat, and the other one end is in water, that is pushing the water. Now here, this is an example of a class 1 lever, because fulcrum is where the oar is resting on the boat. Where the oar is resting on the boat. So there is a longer distance. The arm, the load, water, where the end of the oar that is in the water, it is longer in length from the fulcrum than the distance of the effort to the fulcrum. As a result, the mechanical advantage is less than 1. Here in this case, the mechanical advantage is less than 1. It is an example of a class 3 lever. This is an example of third kind in class 1 lever, not class 3 lever, third kind in, that is less than 1 in class 1 lever. Next we have second class lever. In second class lever, the fulcrum is at one end and the effort is at the other end. The load is between the fulcrum and the effort. So here we have the diagram, simple diagram, fulcrum at one end, effort at another end, and load in between. Now in this kind of lever, the effort arm, the distance between the fulcrum and the effort is always greater than the load arm. The effort arm is always greater than the load arm in the second class lever. So we have the mechanical advantage. Mechanical advantage formula is effort arm upon load arm. Since the effort arm is always greater than the load arm, the mechanical advantage of second class lever is always greater than 1. Now, velocity ratio. The velocity ratio of this second class lever is also always greater than 1. Velocity ratio of second class lever is also greater than 1. So when mechanical advantage is greater than 1, then the machine behaves like a force multiplier. So second class lever behaves like a force multiplier. Is it clear? Then there are certain examples of second class lever. The nutcracker, the lemon crusher, a bottle opener, a wheelbarrow. Here is an example of wheelbarrow. You can see the fulcrum. You must have seen the wheelbarrow. People use the wheelbarrow to collect garbage and dump it at another place or carry load. So wheelbarrow, fulcrum here. The wheel is in contact with the ground, so it is a fulcrum. The material load put inside this, so load is acting here in between, and the effort here. Now effort arm is greater. Effort arm is the distance from the fulcrum to the effort. So fulcrum to the effort. Effort arm is greater than the load arm. So here it is used as a second class lever or force multiplier. Then we have nutcracker, lemon crusher, mango cutter. You are standing on your toes, okay, raising your heel. You are standing on the toes, raising your heel. Or example of some second class lever. Then we have the next kind of lever, that is class 3 lever. In class 3 lever, the fulcrum is at one end. In between, we have the effort and the load at the extreme end. So fulcrum at one end, load at other end, and between the two we have effort. Here we have fulcrum, load and the effort. The effort and the load are acting in the opposite direction. Effort in the upward direction, load in the downward direction. Then the distance. Now we look at the distances. The effort, load arm is always longer than the effort arm. The length of the load to fulcrum, load arm is always greater than the effort arm. So we have the mechanical advantage. Mechanical advantage is ratio of effort arm to load arm. It is always less than 1. Mechanical advantage is always less than 1. Then velocity ratio is also less than 1. Why? Because effort moves slightly and displacement of load is much more greater. So displacement of load is much more greater than the displacement of effort. As a result, the mechanical advantage of third class or class 3 lever is always less than 1. So what is of use? Mechanical advantage is less than 1. Why do we need such kind of machine where we have to apply more amount of effort than the load that can be lifted? This kind of lever is only used for two reasons. One, for gain in speed. Second, for sanitation purposes. साफ सफाई के लिए. So, example of this kind of lever are tongs, chimte, for safety purpose. Okay. So all kind of tongs, whether it is sugar tongs, ice tongs, or tongs that are used by your mother at home. So they are used for safety also, for sanitation also. Fulcrum. Here the chapati is being held and the effort is being applied at the center. So this is an example of class 3 lever. Then we have another class 3, a spade. A spade that is used for lifting the sand. It is also an example of class 3 lever. Then other examples of class 3 lever are boat race. You must have seen a boat race that is being, there are a number of people sitting in the boat on one side and they have got a small oar and they keep one hand like this firm and the other hand they keep on moving in the water. So there is a load. Water is the load. The load at the other end. In center there is effort and fulcrum. This left hand is kept firm and then the small oar is moved in water like this. So it behaves like a class 3 lever. Then there are certain examples of levers found in our body. Okay, you know that our head that is resting on our vertebral column. So the weight is on the chin here, and to raise our head we have to pull our muscles backward. So effort is at the back end and the load is here and fulcrum is at the center. So it is an example of class 1 lever. Then when you take certain load at a hand and you hold the weight on your hand, then the load is acting in this direction. The load is downward and the fulcrum is here and effort are these muscles. So effort in between. It is an example of class 3 lever. There are many more examples you can go through. Please do the numericals.